Okay, we're going to solve the equation sine x equals 1/3. Now 1/3 is not in the trig table. There's, it's not a special angle that sine x equals 1/3. So what I'm going to have to do to solve this is take the inverse sine of both sides. And so what happens is the inverse sine and the sine cancel out, and I get x equals inverse sine of 1/3. Now this is going to be a first quadrant reference angle because 1/3 is positive. But as far as sine x equals 1/3, sine is going to continue to do its little periodic thing, and there's some place somewhere where it's equal to 1/3, and it's still going to hit this graph an infinite number of times. But the inverse sine function can only recover the first quadrant angle. So how do we get all those other angles? Well, pretty much the way we did in the other ones. So we take x equals inverse sine of 1/3, and we say, well, that's going to repeat every 2 pi n. But that only gets us these on the kind of the uphill side of the sine function. How do we get these? Well, so if we switch our models from sine waves to quadrants, this is inverse sine of 1/3. That's an angle measure. So remember that angle measure is going to be what comes out of an inverse function. And so that's going to be here. Sine is positive in quadrant 2, so there's another angle over here, which we don't know. We'll call it theta. Where this has the same sign as this angle. So how do I find this one? Well, it is the supplementary angle to here. So this is the actual value of that. That's the first quadrant reference angle, and it's inverse sine of 1/3. But how do I find it from this direction? What's the actual angle measure that gives us that reference angle? Well, we take pi and subtract that, because this is pi, and we subtract this off, and we're left with this. So our first quadrant answer is inverse sine of 1/3 plus 2 pi n, and our other one is pi minus inverse sine of 1/3 plus 2 pi n. Now working with this one, I'm going to get the pi's together, so I have 2 pi n plus pi minus inverse sine of 1/3. And now I can factor out a pi, leaving 2n plus 1 and so that's my second solution. So my general solution has two pieces. It's got inverse sine of 1/3 plus 2 pi n, and it's got, I can either call it minus inverse sine, I can write it like that, plus 2n plus 1 pi. And that would be, so that's just rewriting the terms, but reordering them. But that would be my general solution. So we use the inverse, but then we have to find the second quadrant when we are doing sine. When we're doing cosine, we'll find the first quadrant and the fourth quadrant, and when we're doing tangent, we'll just have to find that one. It'll either be a first or a fourth quadrant, but we'll only have to hit it every pi.